Hello and welcome back. Sorry, my screen keeps fluctuating. Uh, we are now talking about addition, subtraction, and multiplication of sets. Let me get that screen back. Yeah, I have it back. Okay, so the simple idea is that when you have two sets that look the same, so root 3 and root 3, they basically add up like algebra. So if you had 2x plus 3x, you would say that it's total of 5x. So that's what we have here as well. It's simply going to become 5 root 3. Okay. Then with squaring the set, it's basically 2 root 3 into 2 root 3. So remember that the number multiplies with the number and the root multiplies with the root. So 2 into 2 is 4. When root 3 multiplies with root 3, as we studied before, that root of a into root of a becomes a. So the root of 3 into root of 3 should become 3. So that makes a total of 4 into 3 is 12. Okay. That's similar what I'm asking you in C. It's 2 root 3 into 3 root C. So number with the number 2 into 3 gives me 6 and root 3 into root 3 gives me 3. So that's a total of 18. Then I can also have brackets that multiply with one another. So 2 plus 3 root 2 into 2 plus 3 root 2. Okay. I get what? 2 times 2 is 4. Okay. Now, some of you probably use the FOIL method, the first outside, then inside, and then inside last, and so on. Okay. What I simply teach about brackets is that you need to multiply this with the entire bracket and then this with the entire bracket as well. So I'm going to write it like that. I'm going to write 2 plus 3 root 2 plus 3 root 2 into 2 plus 3 root 2. Okay. 2 into 2 gives me 4. 2 into 3 root 2 gives me 6 root 2. Remember that the number multiplies with the number, the root multiplies with the root. If the root is absent, then you simply get just root 2. Okay, what's 3 root 2 into 2? That's 6 root 2. Okay, and then 3 root 2 into 3 root 2 is 9 into 2. So that gives me 4 plus 12 root 2 plus 18. So that's 22 plus 12 root 2. Okay, I hope that was useful for everybody. Let's talk about this one. Okay, so 1 multiplies with the entire bracket first, and then root 3 multiplies with the entire bracket then. So 1 into 1 gives me 1, and then root 2, 1 root 2. Then root 3 into 1 gives me minus root 3. And this last one should give me minus root of 6. Root multiplies with the root, and the number multiplies with the number. But since this is not the same root, it just doesn't boil down to one number. It is then a combination. So I don't think I can simplify this further. Yeah, we'll just leave it as it is. Okay, and let's do this one. So 3 into 5 gives me 15, and 6 root of 7, then 10 root of 2, and then 2 into 2 is 4, and root of 2 into root of 7 is root of 14. Can I simplify this further? No, I can't simplify this further. So I'm just left with this part. Okay, and that's absolutely fine. So look at this last one on this page, and then I'm going to talk about something different. So 1 into 1 plus root 5 minus root 5 into 1 plus root 5. So 1 into 1 gives me 1. 1 into root 5 gives me root 5 minus root of 5, and minus root of 5 into root of 5 gives me 5, or it can give me root of 25, and then that boils down to 5, and that's absolutely fine too. This cancels out with that. I'm left with minus 4. Okay, so the final answer to this is minus 4. Now, if some of you already noticed this, I could have done it in a different way as well. This resembles the identity that you study in algebra. A minus b into a plus b boils down to a difference of squares. That's what we call it in algebra, a difference of squares. Can I just simply say that this should have been 1 square minus root of 5 squared? So 1 minus 5 gives me minus 4. Okay, still the same answer, a different way of looking at it. Similarly, I could have done this question in a different way as well. I could have just done a square to ab plus b square, and that would have given me the same answer. But since I wanted to teach you multiplication, I didn't do that earlier. Okay. Okay. I have some more questions here. Okay, let's look at example number 25 now. It says simplify the expression. So I know that some of these roots are getting added, subtracted. Let's add and subtract the ones that can be added and subtracted. So 7 root 3 and 6 root 3 gives me 1 root 3. I don't need to write 1. I can just write root 3. 5 root 2 plus 4 root 2 should give me 9 root 2. And that's absolutely fine. Let's look at part B. Let's just remove the brackets and simplify. So first you multiply root 3 with root 3. What does that give you? It gives you 3. Then root 3 with 7 root 2, a negative sign outside. So the root multiplies with the root and the number multiplies with the number. So 7 root 6 should be your final answer. Then I can also ask you to simplify expressions that look like this. Now, what's the simplification there? You just learned how to simplify this root 18. Why don't we do that? Okay, right now we're just talking about root of 18, nothing else. So I'm just going to take up root of 18 here, 2 into 3 into 3. So these two threes can be put together and they can come out outside. So this can be written as 3 root 2. Now what I want to teach you here is that now you can split the denominator. You can say that this denominator is basically 12 over 3 and 3 root 2 over 3. That gives me 4 minus root 2. Okay, 3 times 1, 3 times 4, 3 times 1, 3 times 1. That's what I've done. Okay, let's do this on the next one as well. 98. 2 times 49, 7 times 7, 7 times 1. So root of 98 can be written as 2 into 7 into 7. Okay, that's 7 root 2 at 14 plus 7 root 2 over 21. Now, can I split the denominator? Yes, I can. Sometimes the question is going to have a very specific requirement in terms of what form you should have. So you have to follow that form. That's 2 over 3 plus root 2 over 3. Okay, I hope you can see that. It's a little jumbled up right now. But all I've done is I've split the denominator and given you two different. Okay, that is the end of this video. I will be back with rationalizing denominators. Thank you for watching.